This is the Amp Hour Podcast. Released June 30th, 2019. Episode 449. Pulled from a working environment.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hey, nerd. What is up? You know, summertime in the States. So
Summertime, yeah, winter over here.
Spending lots of time in the lab. It feels like every time the weather gets nice, I'm like, yeah, I should probably do some more work.
Right.
So,
I thought you just, because in wintertime you get all depressed and, you know.
Yeah, I think that's what it is.
Then you've got to shovel snow and...
Right, exactly. And now it's like, oh, the sun's up till 9:30. I could stay in the lab a little longer, that kind of thing. So I try and get out once in a while, but I'm not great at it. Get out once.
Beautiful.
Yeah. How's it going down there? Down under.
What, weather-wise?
No. Life-wise.
Life-wise? Busy.
Life, you know.
I'm away next week, though. I'm saying bugger it. I'm going to go and walk about next week.
Yeah, cool.
Yeah.
Cool. We will have, I will be posting, I did a bunch of recordings at Teardown, which is the conference I was at last weekend. And that works out well because I will post them next week. So I think I have like 6 about half-hour interviews, so I'll do them in parts or something.
Right.
So people seem to like that. Yeah, that's good, though. And cool. I got to take a really cool two trainings while I was there, actually.
Do tell.
I usually don't do trainings. Usually I'm just kind of busy jibber-jabbing my head off with people that are there. But this time I was like, no, there's 2 FPGA trainings I want to take, and I'm very excited about all the open source tools. We've had Cliff on the show. We've had Peter on the show a couple times. So all the open tool chain stuff that's happening right now. I think people ask what is the most exciting thing you think is happening in electronics these days, and I think open tool chains and RISC-V are the 2 things that are some of the most exciting things that are happening, and I got to do both, so I was really excited about that.
Right.
So Peter,
but specifically FPGAs, you said.
Yes, that's right. So the first one was
Do you have a target? Do you have a reason why you're getting into FPGAs?
No.
No.
Like I said, I'm just excited about the tool chain stuff. I think that I don't know, it feels like something big, I don't know what it is, but and you see it more and more places, it's especially as more image processing stuff comes online. It feels like it's just a thing that's happening. I don't know. I don't know how to explain it.
So we're talking about FPGA tool chains here. That's
right. The ICE40 and the ECP5 and then the Xilinx one that's coming online. So this is all Yosis and NextPNR. What's
Yosis and NextPNR?
So Yosis is what Clifford Wolf and team, I think, developed. But Yosis, oh man, I'm going to get this all wrong. I think Yosis is I know NextPNR is the place and route because it's in the name, PNR, place and route. So whatever comes before place and route, what is that?
God, it's been so many years since I've done FPGAs now.
Sorry, some people are cringing right now. Sorry about that. But when you go from Verilog to a netlist, I think, it's whatever that interpretation layer is. It's not compilation. I want to say compilation, but it's not that. Anyways, that's what Yosis is. And I'll add the links to all this stuff so people can go and look this up if they want to. So
are these different? Say, take the Xilinx part, for example. Is this an entirely different tool chain from the Xilinx, or does it work like, say, the Altium one, where it simply was a nice sort of, GUI interface layer and then just called up the Xilinx tools at the command line level and just handled it all for you?
No. So this is the one that they reverse engineered bit streams on multiple parts.
Oh, right.
And then they developed tools that basically allowed them to then go and create exactly the same bit streams.
This concerns me. If I was doing professional development and you're talking about they had to reverse engineer bit streams, I mean, FPGAs are insanely complex, the most complex devices on the planet, right? It's why the Xilinx... come on, it's why the Xilinx and Altera tools are... How big is the download now, right?
Oh, it's why 20 gigs probably.
Yeah, 20 gigs, right? It's why they're so massive they're so, I'm not going to use, well, the bloated, it's probably not the right word, they're probably that big for a reason, is because that there's just so much stuff in them. And when you're using some new tool that has to reverse engineer the bit stream, that makes me scared that I'm going to run into some obscure bug that's just going to be a project showstopper.
Totally possible, but I think that the thing is the companies aren't going to give up the. I think they're trying to get the companies to buy into this, right?
No, that's no, but of course they're not. The Xilinx and Altiras of the world. Sorry, who are they? IBM. Who owns them?
Intel
IBM.
now, yeah.
Intel. Sorry.
Yeah.
Intel own them.
Yep.
Yeah. Do they still call them Altera, or are they Intel?
You see, anytime I get an ad these days, it says Intel FPGAs. So
Intel I thought so as well. Yeah. Anyway, I'm still going to call them Altera. Whatever.
That's fine. Yeah, I think it's still understood.
Yeah, that's their business. I mean, they have thousands of programmers working on this software. Like it's that complex, and that's their business.
Yeah, so I think
they
you were talking
parts,
about the 20 gig thing, and I think you're like the size of that thing. I think that's because that's across the entire spectrum, right? That's not
it's
just
across the entire spectrum, and they have to have legacy support and all the rest.
Exactly.
But,
so it's not just Spartan 6 or even Spartan 4 or 2, whatever.
Well, but that's the problem. There's so many variants of all these.
Sure.
And it's like, and you, of course, Murphy being Murphy, you're going to need this particular part that's, not supported or is buggy in some third-party software because nobody else is using it yet, has actually used it yet. You're the first person to use this, /2 variant of this part, with this new software. So,
Sure. But I mean, so if you look at what's actually happening here, so right now there's only 3 parts, I think, that are not even officially. I think
it's good to focus on a couple.
That's right. Yeah. And and Lattice has been really supportive as far as I can tell. I met some of the Lattice folks are really nice.
Okay.
This is an older part. It's an older part. The bitstream, I don't know what the status of it is. Like, it's definitely like a reverse, I think it's like under fair use so Clifford's been on the show. Then Peter interviewed FPGA Dave and Clifford at Chaos Communication Congress last December, and that's when he did our traveling correspondent thing. People can go back and listen to those. But I don't know what the status is of like how it all works out in like legality and whatever else. But from my perspective, I'm really excited about it because if something like a Lattice, bought into this thing, basically now you have a bunch of people that are willing to donate their time and their talents to tools like this. I think it's just really cool. And the crazy thing, and so this is what was called out in Peter's workshop. So Peter did a workshop there, and he and basically, you watch these tools happen. It's a really nicely done workshop. It was like a Joe Fitz also has been on the show, and Clifford have done these workshops in the past as well. But basically, it was like you click go, and by the way, Yosis is a synthesis suite.
Right? Yes.
So it's Yosis Open Synthesis Suite. That's a recursive acronym because the Y is Yosis, and then Open Syn Suite. Anyways. So that's synthesis, but basically all of these tools, you click go, and it's like 20 seconds, Dave. It's insane, and they actually timed it. They said it would have been an 8-minute synthesis, and then place and route and everything else.
Yeah, but it's just faster. Is that a big deal?
I think that can definitely be a big deal. Like, think about like iteration cycles when you're like. So I don't know about you. I was telling some of the people at this training, back in my old days when I was doing FPGA stuff. I'd click go on a thing, and I was doing mathematical modeling and like Simulink, which is like the
and you
go
have lunch
tool.
and you come back. But they've got to have something more than just speed. I mean, there's got to be we're still talking about synthesizing Verilog, right? We're still talking about Verilog and VHDL code. So you write your Verilog or VHDL code and you hit Verilog, go, right? And it's only Verilog?
As far as I understand it, yeah.
Right, okay. Well, anyway, you do your Verilog code, you hit go, and so if their only thing is that they're faster,
No, it's not just
I don't see that.
So, okay. So what's the one thing that's always been missing in an FPGA? What's something that you can do in a micro that you can't do in an FPGA? It's a trick question, of course.
Well, you can run sequential code.
Sure, and that's actually that's the big difference that I will come back to. But I was actually thinking you can switch vendors, right? If you write C, now granted, there's going to be some level of trouble there. But if you switch from a Atmel part to an XP part, like basically GCC handles that without problem. If you do that in an FPGA, you have to start over pretty much. Like you basically can't target multiple parts.
That's the whole idea of a high-level definition languages like VHDL, like Verilog and VHDL. That's the whole point. And when you change vendors, you've still got all the little nitpicky, stuff. Same with micros. You change vendors, you've still got the same picky stuff. But your C code is still got to transport over, right?
Yeah, the code itself.
I'm not sold on this yet. I'm not buying this.
Well, anyways.
No, sorry.
I don't mind if you're not excited about this. I think this is very exciting.
Okay. All right.
And so these tools are now open and fast, and I'm sure I'm missing other benefits.
Can I have another little whinge? Another question. It's not a whinge. It's a question.
Sure.
Aren't most of the FPGA tools still free for like these sort of low end parts?
I can't say I've used an FPGA tool in a long time, Dave. This was my return to FPGAs.
They were. Okay, so they were last I checked, right? For sort of like the low end FPGA, hobbyist one-man band type FPGAs that you're going to want to use. The tools are basically free. So what does open source bring to the table in that case?
I would think other things are like...
What does it be in open source bring?
ASCII-based stuff. I think it's like ASCII outputs. So like right now, if you go and hit compile on not compile, if you go and start using a Xilinx tool, it's all binary stuff, and so it's not, you don't have visibility into lower level stuff.
Yeah, but
some of us use revision control,
like
Dave.
Altium, right, okay, right, yeah, no,
and not
fair
in
enough,
DaveCAD. That was fun. That was a fun DaveCAD thing where you said,
how
do you do revision control in DaveCAD? It's tape and scissors,
and it's git paper.
Git paper, yeah, right.
It's git paper. Anyway, people are talking about Twitter. We just we're both on Twitter and we banter back and forth. Anyway, see the advantage, like when Altium did FPGAs, for example, right? The beauty of that is that it was all high level. You could drag these blocks in, and it just sort of like seamlessly worked. And yes, you could go between different vendors and stuff like that. You could just drag it in and it would all sort of like handle that for you. You could drag in a processor core and it'd just work. And then you could convert some of your C code to Verilog or VHDL, right? It had a C to HDL synthesis thing, converter. And it just, from a high level point of view, it was really magical. So if you wanted to make a real simple application, and you could even do it like from schematics and things like that. You didn't even have to write any Verilog and things like that. So from a high level point of view, it allowed you to use an FPGA very simply. Where it actually came a gutser is when you wanted to do like really serious projects, right? Really, where you had to get to the nitty gritty of stuff. It just all that flashy high level stuff just got in the way, and kind of didn't let you do the job. So
right, yep,
yeah. So I like, and it was really very nice system. And if this open source one is just, well, it's open source, so it's already competing against a free tool. Okay, it's open source, but nobody really cares about open source as long as it's free, right?
I disagree with that.
No, come on.
I put it in PCB land, Dave. There's tons of free PCB tools. I care about open source.
Okay, but nobody using KiCad cares that KiCad's really open source. They don't really care. All they know is that it's good and it's free. Right?
I would say that it matters. It has saved my bacon a couple times that it's open source, because people have been able to modify and write plugins for it without any issue. And those plugins have actually saved my bacon.
Fair call.
Yeah.
Okay. Fair call. But most users...
Yes, I think casually...
You are so intimately tied in the KiCad community that I'd say you're not the average KiCad user.
I would agree with that, yes.
Yeah. Right. All they want to do is download the latest executable, and if it doesn't do something, it doesn't do it. Right? They'll just find another way to do it. Right? It's like one of those,
I think you're just looking for things that you like picking fights about open source here. Anyways, some of your points are valid here, but I'm not the best. I'm not the best proponent for this.
Yes, exactly.
No, I'm just saying that like even for the FPGA stuff, I don't think I'm the best.
Because I come from the FPGA. Intimately involved in the FPGA community, right? So I've got my own, things about this. But so it compiles faster and it's open source, cool.
Mm-hmm.
All right. But if it's competing against an already free tool from Lattice or from Xilinx, then okay, that's going to be tough.
I guess so. I mean, you could always switch back to that though too. It's not like
yeah, sure. No, because that's the advantage of writing in a HDL, a high definition language, is that you can switch back. There's a little bit of grief there, but generally speaking, shouldn't be too much of a problem. So,
right. Yeah. So
anyway.
I was getting back to FPGAs for the first time, and basically, I mean, like it was like pretty much a beginner's workshop, but it was interesting to watch it happen, and honestly, just to switch back into that. I mean, I don't know the last time you wrote HDL stuff, but it's been a while for me.
Yep.
It's like
I would have to. It's been so long. I would have to start from scratch.
I'd have to go back and
exactly. So I'd have to get out the VHDL for dummies.
Yeah, I started when I started doing FPGA stuff. It was always VHDL, and I had done a little bit of Verilog.
Yeah. When I started, probably 15 years ago was the first time I did it, probably at least. And like a VHDL was the thing, and now it's like seems like I don't know. Does anyone let us know?
I think some people still do.
Some people still do, but Verilog seems to have taken over.
I think the chip industry is using Verilog mostly. I think that it's it's
it won the war. You think?
It's never going to be like all or nothing, but it's
of course. But,
I think that like I said, like tools like this too will also help to people that are coming in, if there's accessible stuff, then I think it'll be more likely that it'll be Verilog than VHDL.
But Verilog probably it reaches that like 80-20 ratio. There's a ratio thing, so it's probably once it captures like 70-80% of the market, then it's it's done.
And so like because I came from the VHDL world where it's like you can't type a single thing unless it's like you have to like type it in multiple places and it checks everything and everything has to be like perfect. Verilog's just like do what you want, man. Just like
bit loosey-goosey. Yeah.
And that did not serve me well.
Right.
Like I typed one variable wrong. I think instead of time, I typed Tim, and it was like the synthesis tool is like, hey, I noticed you made a new variable here. I'm gonna warn you about it, but I'll just make a new one. It's cool. It'll just be over here when you need it. It's like, no, don't do that. Tell me I'm an idiot. Come on, I need to. So it was a good. It was good.
I've got a segue.
Okay.
I've got to say, speaking about sort of like, cross-platform code and things like that, the micro supply that we're working on, right, or David's working on, we're working on the USB interface, right, because we've got like a USB Type-C power delivery controller chip in there, right? So I'll send you a link here. Mm-hmm. Here we go. So you know what I'm talking about. And we're actually, so hang on, it's hard to talk and type at the same time. Now, we're using a Richtech RT1716 chip of the week. It's a programmable USB Type-C power delivery controller chip, right? So it sits on the USB side of the isolation transformer. Right, so we've got, power comes in, it's isolated, of course, right? So it's an isolated power supplier, spoiler alert. And right, so it handles the negotiation with the Type-C USB port, because we need to deliver more than your 2.5 watts, right? So we have to negotiate the higher power levels and stuff like that. So you really need a chip that already, handles all the protocol, the USB power delivery standard, PD. And so we're using this little chip, and unfortunately, it's a good chip. It's the one we wanted, but unfortunately, the development information that came along with it wasn't that great, right? So David's scratching his head, going, "Oh, how do I use this damn thing?" Right? And he couldn't really figure it out. But then he determined that it should use the standard protocol, right? Well, obviously, right? It uses USB Type-C power delivery as a standard, right? Yeah. So I can't remember the name of it. Anyway, so it uses this standard. And so what he did is he went to a Texas Instruments part, which was another Type-C, a competing device, and he used their development information, and he tried that on the Richtech one, and it just worked, right? Oh, really? So he's stealing the Texas Instruments development information and the code and software and stuff to talk to this Richtech controller, and it's all just working. He says it's sweet. It just, he can't believe how good it is. And now, in theory, he's written his code so that we should just be able to, if say this Richtech part suddenly went obsolete, right, end of life, and we're 5 years into the product, then in theory we could just switch it out with any other power delivery controller chip, and our code should still just work. That's in theory. So anyway, we've got lots of cool functionality now where apparently we can do remote debugging of our main microcontroller over the isolated serial interface through the Richtech USB power delivery chip, and we can update firmware over that and everything. It's really quite
confused.
Cool.
So it looks like there's a I2C interface. Is that not what you're using? It's serial in this?
Yes. Oh. Yeah. Oh, sorry. Well, we're using I2C. Yes, there's an I2C interface, and we have another micro on that side.
Oh, okay.
So anyway, so we can update. Yeah, we can update our firmware, our bootloader code. We can do remote debugging over an isolated serial USB Type-C cool. interface, and it's really quite advanced. David's like just wetting himself. It's so fantastic. Being the software nerd that he is.
Yeah, that's great.
It's granted it's complete overkill for a product like this, but it's kind of David's terribly excited over it. So
these are not.
It's just really cool.
Tiny parts too. That's chip scale packaged.
Yeah, I'm not sure which one we're using, but that looks like it might be the only one. Anyway, pain in the ass. But it's cool. So yes, all this cross-platform kind of stuff is. So
what does that mean by cross-platform? It's just that it talks to each of it talks to Mac, Windows, and Linux, no problem. I'm using the wrong term there. Cross-vendor. Oh, okay.
Cross-vendor. So it's in theory we can move to any vendor and we don't have to change our code and our development system.
So is it like the registers are the same internally? Is that kind of the idea?
Yes, I believe at the register level it's identical.
Wow.
Don't quote me on that though.
It makes you wonder if if the Richtech was supposed to copy the TI thing, or maybe it's like a standard even. I don't quite know.
No, I believe it's part of the standard. Huh. So he's actually following the standard, and it's just working. It's great. But granted, right, this has taken months. Right, this has taken months of full-time development just to sort out this USB power delivery stuff. Yeah. So just be aware, folks, if you're developing I just whack in a USB chip and I'll get power delivery and I'll get, I can download my firmware to my product, and it's not going to be that easy.
Right.
There's a lot of effort, but once it works, it's pretty cool.
Yeah.
But there's a lot and David's really good at this stuff, and he's spent months and months trying to figure it out.
Yeah.
So, yeah.
Yeah, I'm looking at the register side by side, and it does look like they're the same. So that's great.
I think I do believe they are.
Yeah.
So
that works out really well.
It's very cool. Anyway, yes. He was like stunned that it actually worked.
Mm-hmm. Yeah.
Yeah. So,
That's great.
Very impressive.
I know you had a segue, and I wanted you to do that, so that was a good segue. But I did have one other training I wanted to talk about too.
Oh, okay. Well, segueing back.
Yeah, well, not
Or
really.
just-
It's okay.
We're looping back. Okay.
Looping back, yeah. So,
Yeah.
so the other
Go
one I
to.
did, yeah, go to 10.
Oh, this loop rubbish. Yeah.
So the other one is actually a link in the show, or not the show notes, but on the subreddit, and it's the FOMU, and we've talked about the Tomu briefly in here before. So we've had Tim Ansel is on the show before, and so Tim is the one who did the Tomu, which was a tiny little USB thing. It plugged into your USB port. It like disappeared in there effectively, and I kind of never really got it. I didn't quite understand. It had a USB, or sorry, it had a LED on there. It had a couple little like touch interfaces, like cap touch thingies. I
don't actually remember it, but I can visualize.
Yeah. It looks like one of those, like how you can plug in a wireless receiver for your
Right.
wireless mouse kind of thing, like that
So
size
you
thing.
didn't quite get that, but now it's got an FPGA in it. You suddenly get it because you're all excited about FPGAs at the moment.
Well, yeah. So I mean, it wasn't even. It's not that a light came on. Like I asked, I was like, so like, what's the point here, guys? And some of it is just. I think the Tomu, even the Tomu is the micro based one, was basically to get people programming. That's kind of the idea, is to get people programming and doing stuff, whatever. This one as well. Like, so I look at it as a hardware person, and I asked Tim. I was like, it's Tim and Sean Zobs Cross. So Zobs is the one who worked on the Novena with Bunny. So that Bunny and Zobs worked together a lot on hardware software stuff. So Sean did the hardware and a bunch of the firmware for this, and then Tim's also pushing a bunch of FPGA stuff these days. So that's so Sean's doing a lot of this stuff. And so I was talking to both of them. I was like, so like, what is the point of this thing? Like what is it you say it does here? And mostly because the hardware person, I look at it and it's just an LED, like it's a tricolor LED, fine, neat, cool. And then like 4 tiny little, cap touch, or I think they're even just resistive touch pads that you can pair them up to get cap touch or something like that. And so I was like, well, what are you guys doing here with this? Why is this here? And so Sean's like, hey, you should come to this workshop. I'm going to show everyone what it is. And so it's called, the link that I'll share is the workshop slides, but it's,
I'm looking through them now.
Yeah. So the 3 levels of FOMU are, Python, then RISC-V, and then FPGA. And so all the way through the workshop, what you're doing basically is you're just loading bit streams to start with. But you load a bitstream on this FPGA.
Mm-hmm.
The bitstream has an FPGA in it, or maybe it's more than just a bitstream, but it has a microcontroller in there. It's already got RISC-V microcontroller with a Wishbone bus. It's got a built-in USB controller, and then it's got Python already compiled on top of that, MicroPython rather. So basically what happens is it pops up as a MicroPython prompt, and so you just start writing Python. You can access the LED. Then you dive down a level, you go to the RISC-V thing, and then you can compile your own C code for the RISC-V that's underneath there, right? So now you're not at the Python level, you're at the C level, right? Then you can basically access the Wishbone directly, right? So Wishbone bus,
yes,
Wishbone bus, right?
Wishbone, yes, that's what Altium use. Altium use the Wishbone.
Right, so that's bus, like a way, like a standardized bus in FPGAs to like add peripherals to a microcontroller, that a soft CPU that might be in there, and you can basically write your own devices that then hook into the Wishbone bus. So you can talk to them with a soft CPU. So in this case now, you can then from your computer through the USB port, you can then directly modify the memory locations on the Wishbone bus. And so basically from your terminal on your computer, you were then writing values to a Wishbone bus. So basically, if you think about like you're running a program on a CPU and you wanted to halt it, you could then go and change not a value in the code, but actually a value of like a device on the bus, which is like pretty crazy. Then we basically ripped out the CPU. I might be getting this order wrong, but then we ripped out the CPU, and then we could just write just random, not random, but basically just low-level Verilog that does the same thing. In all the cases, we were just changing the LED, color. It wasn't anything crazy or anything like that. But in each case, it was showing like the different levels of software. And I told Sean, I was like, basically like anytime you hear a JavaScript person saying they're full stack, you have to like laugh in their face now because it's like you're not doing all this stuff, you know?
Yeah, no, you're not doing hardware, soft cores, you know,
exactly.
You're not doing FPGA bitstream infrastructure.
All the way down to the bottom,
like,
And of course, there's always like, you'd be like, well, you didn't design the FPGA, you know, you didn't
See, this is what I was talking. This is what Altium. This is what allowed you to do it so trivially in Altium. That was the magic of it. This is a similar sort of thing. It's allowing you to use a soft core. It's using the Wishbone plugins, and you can just yeah. Right.
Yeah. So I had never done anything like this, and it was, I mean, super cool. Like it, you know, it took a while to get all the software installed and stuff like that. But you know, it's getting to the point where a lot of the software was just like packages that were just like installable from Linux even. So
right.
Pretty cool stuff.
Okay.
So,
no, this totally reminds me of Altium. Yep. It's been there.
Yeah, and I'm sure that there's people like I'm not doing.
Except it has Python, because Python wasn't a thing back then. But now it's,
right. But yeah, it was, I mean, super cool to do those two things. Kind of a reintroduction to FPGAs. I think you asked at the beginning, like, why do I even care about FPGAs? Well, like, I don't really know. I don't really have any projects that need them right now. But like, when you need them, you need them. You know, that's kind of the thing. And so,
of course,
having the tools now is good. And if the parts are big enough to put like small soft-core CPUs on there, like that's kind of cool too. Like, it's not necessarily the most power efficient, probably not the most low cost kind of thing. But you know, if I'm doing a design and I'm feeling like something's going to change in a big way at some point in the future, yeah, maybe this would be a good fit. You know, I can put something on there and just reconfigure the whole damn thing at some point in the future. So I found these very energizing workshops. So nice job to both of them and their teams.
Excellent.
They did a great job.
Done.
Yeah. I don't know. I don't know if you ever found a good use for FPGAs.
I didn't. Yeah, no, not really. I've never worked on stuff that needed so much parallelism.
Yeah, I always figured like stuff that was like signal chain based stuff. So like, you need to like do things fast, and you need to like, you know, like I always think like filters and things that have like big data flows coming through them. Maybe not, you know, for smaller parts like this. No, I haven't worked
on projects like I've used FPGAs for the sake of using FPGAs because I was at a company that
you had to like,
you know, was focused on FPGAs.
Things.
You know, you got to showcase stuff. You know, so look, I can get a 10 gigabit per second Ethernet interface decoding. Great, you know, fantastic.
Yeah.
Okay. But I don't really have an actual project application for it. So.
Right.
Yeah.
Oh, sorry. There's one more thing too, and I was just kind of flipping through the slides too. There's another thing called MyGen and LightX, and I don't know which one's which, but basically now it's at the level where so now you have these low-level tools, and maybe this is a reason people like this stuff too. So now you have these low-level tools that allow it to like synthesize and do all the other stuff, but then you can LightX and MyGen, I think, are Python-based that are written on top of this, right? So like you were talking about like doing big blocks of things. Now it's basically like calling hardware blocks and assembling them all together. And that's another thing that like, because now the tools are open underneath, you can start to stack stuff on top. Like this is the same thing I like about KiCad, is that all the Python tools are based, like the ability for someone to change KiCad and do like a tool that I can use and modify files is pretty trivial in Python. Trivial for other people, not for me. And but it's because the tools underneath are open. So I think that's the layers we're getting to, is that if you're already all the way down at the bottom and it's open all the way from the bottom up, I think that enables some of the high level software tools to be scriptable and turn things around faster, I think.
We are living in a world where things are getting easier and easier.
Yes.
Yes. Because all these smart cookies have done all the
exactly
hard work to develop all this stuff.
Right. Yep. I agree with that.
Yeah. Very cool.
Yeah.
All right. News, I guess. Raspberry 4. Do we care? No, not really.
No, it's interesting.
Raspberry Pi 4. No, come on. It's not interesting. It's a new Raspberry Pi.
It's not interesting to you? I think it's interesting.
Why?
It's got dual monitor outputs. It's USB-C.
Whoa, yay.
It's $35 still. I don't know. It's
okay.
It's a new core. I don't know. I think these things are interesting. Maybe not as interesting, but
SparkFun have another development board. Yay.
That one's kind of interesting too.
The Artemis. Okay, yeah, they're all interesting if you're,
Do you know what it is?
In some niche way.
Do you know that one is?
No, I don't know what it is. No.
So that one is so
it's an ARM Cortex M4, like.
Right. So what they're doing though is like what do they call it? It's a machine learning algorithm.
Yeah.
You can tell I haven't reviewed this in a while. But basically, it's a.
Is it one of those? Yeah, it's one of those edge cloudy things.
Yeah,
right?
Where is it in here? Sorry. It's so basically like when you're doing like machine learning on something, right? You basically have a model. Like so, you have like servers. So when I did that AI course, that open AI course, basically it was doing like machine vision on a thing, right? So basically, you feed in a bunch of images, and then the machine kind of iterates on it, and starts to find edges and basically creates these variables that then allow it to then go and recognize these things in the future, right? And that's the model that it creates. The idea is that it then loads this down onto a smaller device. And in this case, it's a Cortex M4, which is kind of crazy. TensorFlow, God damn it, that's what it was. So TensorFlow is one of these things that allows it to like learn over and over and over again. That's what I think Google came up with. But there's a new TensorFlow for microcontrollers where now you do all the actual value creation. You figure out all of the variables rather on a big server, and then you load it down onto a micro. So the micro's not right. It's not crunching on it. It just can then.
It's not doing the low level crunching. It's you're working on more abstracted.
Yes, that's right.
Data, so to speak.
Right.
Yep.
So the thing that SparkFun just announced is the Artemis is like this little Cortex M4 module, right? It's actually like looks like a pre-cert, but I don't think it's actually pre-certified. But the idea is it's got a microphone on there, I think, and then you can then drop this onto any kind of simple product, much like how you or I can go and buy a simplified like cell module where we're not actually putting a cellular baseband chip on a board. We're just putting down a module, and then you're interfacing with like a serial bus. This is now the same kind of thing, but doing it for voice interaction. And so that's why all the things say hello to the I think that's Alistair's thing.
I thought it implied voice.
Yeah, right.
Yep, stuff.
And it's pretty cool, I think. I mean, like, it's not a trivial thing to like add voice control. Like we think it's everywhere because it's all the Amazon products, but like there's a lot of computing that goes on there, and obviously that's talking back to a server too, right? So it actually, some of the low level stuff oh, sorry, I'm going to preempt everyone. I'm going to say a word now that your echoes are going to not like. But if I say like, Alexa, play some jazz, right? At least the Alexa part, when I say Alexa, that's actually internal on the device. The play some jazz is what's sent up to the server, right? So it actually recognizes that stuff. The same thing though, if I want to have a trigger word, so we had Bernard and I forget the name of the company, but we had people on the show before who were doing the same kind of thing. They did it on like a really, really big processor that was like a ARM A11.
Nope.
It was something big, but it was the same kind of idea of like having like an audio trigger. Now this is basically that and shrinking it down. So,
right. I've done a video on voice recognition from the 1980s.
Yeah, I remember that one.
Tandy Radio Shack VCP 200.
Yeah. That was a great video.
Yeah, and it's and I built it up on a breadboard, and I used the original chip I had from my junk bin from the 1980s, and it's amazing what you could do. This was like I can't remember. Was it a microchip? They weren't called micros. They were Arizona microchip back then, or they were what was their former company name before that? Something.
I thought it was like General something, wasn't it?
General Semiconductor.
General Instruments?
Was it? No, General Instruments. General Instruments, yeah. That's it. Thank you.
Yeah.
And I think it used one of the early ROM-based, like 1K PIC processors, and they shoved voice recognition in 1K.
Right.
Like they did 1K of programming memory. Like insane.
Right,
I think, from memory. Anyway, I'd have to look at the details. We can post the video down below, but... Yep. Yeah. And you could do, like, it had instructions. You could do start, stop, turn left, turn right.
Right. That's like the phoneme detection, stuff like that.
Yeah, phoneme-based thing. Right. Yep.
Yeah.
And it worked. Yeah, it was cool.
I think this is like, I think at the lowest level, it might be doing some things like that. But like basically, instead of having it hard coded into memory, now you can have it retrained and stuff like that.
Yep, all that sort of jazz.
Yeah.
Cool.
Yeah. Cool, and that's the thing. Like, I think that we benefit from stuff that is like modules like this. Like it really enables a lot of things. Like I could never, like I said, I use cell modules all the time now. I don't have the ability to go and do a baseband chip, put that down and all the.
You wouldn't. No.
Yeah. Right.
No, you'd be foolish to do it, and then you've got compliance issues instantly.
Right.
Because you've got a bloody transmitter.
Right.
Right.
Yeah.
It's not just a regular EMC emission. Right. It's not just a regular board that has transitions and you've got some EMC stuff to deal with. No, you've got an intentional transmitter. Like that's when the FCC come around with handcuffs. And like Whereas if you just got your little processor Arduino hat board and you're selling that on eBay or something, like no one cares, right?
Right.
But when you're selling an intentional transmitter, someone's going to care eventually.
Right.
So, yeah. Anyway, more news.
Yeah.
We've talked about this, and it involves a former guest, Robert Ferenak, who does the PCB tutorials, the excellent Altium and PCB design tutorials.
Yep.
He's probably the only one in the world who's actually doing, that's his full-time job, he does PCB design tutorials. And he offers these courses through Udemy, which we've talked about here many, many moons ago. It's one of those, online publishing platforms where you can publish, anyone can make a course, like a video type tutorial course, publish it on there, and then you get people join and run your program, and they give you a pissant cut of the money, right?
That's right.
30%, by the way.
Yep.
Which is nothing, right? They keep 70%. Thank you very much.
Right.
Don't. Anyway, so he's had his content on there for years. And, he's got 10 or 20,000 students, which, as he explains in video, he goes through all the finances of it, and he goes, this does not make me rich. It didn't even pay for the development of the course.
Yep.
Because Udemy screw you on price and everything, as well as your cut. So he gets about $4 per course sign up, which is anyway, nuts. But he just got an email from them. Udemy are changing their terms and conditions to now say that everyone who publishes content on there, it must be exclusive content with us. We own the rights to it.
Yeah.
It's bugger off. So if you're thinking about using Udemy, don't. If you already have content on Udemy, remove it now.
Yeah.
Before the July 15th deadline or whatever it is. Yeah. Just don't. That's just ridiculous. Sign over your content exclusively to Udemy. That's mad.
Yeah.
Madness.
Yeah.
Anyway, that's a dumb move.
That's a dumb move.
So, yep. And he's, rightly upset about this. So
Yeah. It's that's rough.
Yep. So, because apparently, one of the crux of the things is, okay, right, he's got paid courses on there, but he also offers some free courses on there. And he's got a free course on there, which Udemy actually promote to buggery, right? So, everyone looks at his free PCB tutorial, Altium Designer course on there, I think. Yeah. And a free course. So, they promote it. He's never earned a cent from that. And now they're demanding that they own the rights to that. That he's never earned a cent from. It's got to be kidding. Yeah. Anyway, that's just ridiculous. So, wanted to point that out. So, go watch Robert's video. We'll link it in down below.
Yeah, and if you're thinking about Altium training, I think that's it's basically, it's him and the actual official Altium training, and I think that he does some good stuff. So, we
is it official?
No, his isn't official. I'm saying there is official Altium training.
Oh. Yes, there are. You can pay to go through Altium.
Yes, exactly.
Altium's approved courses, or you can, take Roberts. I don't think there's anyone else who's offering that.
Right, and he does more in-depth stuff too, like the taking it actually through development of a board and stuff. So that's cool.
Oh, yeah, and not just any board, but a high-end DDR3, DDR4 processor, really high speed. And IMX6 processor and the whole works, right? So really complex stuff, really complex project. He takes you from soup to nuts, straight, all the way through. So that's why it took him a year, and he says $100,000 to actually develop that course.
Yeah, I believe it.
So that's totally. Absolutely. It could cost that much easily.
Speaking of big dollars, I've been thinking about, so after we had Pete on the show a couple weeks ago, Pete Bevilacqua, who was the antenna designer, I've been doing my RF research and stuff like that. And I was like, I wonder how much it would take to buy. And so Pete developed an open source VNA that didn't actually make funding, and so it didn't actually get made.
Okay.
And so I started looking around, though. I was like, well, what actually else is out there? Because, is he the only one that's done this? And it turns out there are others out there. And so you and I were talking a little bit before the show about, is it better to do like a low end? And I was asking about this on Twitter too, of is it better to do a low end type of thing, or is it better to kind of dive into the used equipment market and hang out on
We're talking about a VNA here, a vector network analyzer, and you're talking about 3 gig. You're not talking about right. 20 megs.
Right. There's I'm not in Shariar territory yet,
Right.
Because he just did a review actually about some that custom kit for like an old HP. It was like an add-on.
30 gig or something. I don't know.
It was something. Yeah. It was something.
He does these
very crazy.
Yeah, he gets these insanely high frequency.
No, I think it was more. I think it was 80 gig. I think it was up in right. Yeah, it was like it was radar territory and above. I think.
Right. Yeah.
So
insane.
Yeah. But we were talking.
And he gets these. I don't know how much he buys those broken bits of kit on eBay for, or where he gets them from, what auction house he gets them from. Busted, but he actually repairs these 30 gig, 80 gig things, and then he's got this $200,000 bit of kit sitting in his lab.
Yeah.
Well, I don't know how much he bought it for broken, but
he said in the video, I think it was like $6,000 or something.
Oh, I was going to say it must have been. I was going to guess $5,000. Yeah.
Yeah, he was very thankful for the Patreons. He had thanked them for that. So
right. Oh, okay. Yeah. Right. I hadn't.
But it was still like a lot. It was still quite a lot.
Yeah. No, that's a huge amount to buy a broken one and hope that cross your fingers and hope that it's not the
right.
The $50,000 magical component in there that you can't buy. That's broken. So gutsy move.
Maybe it's this one. Maybe it's 13.5 gig. Maybe I'm wrong about this.
Anyway.
I don't know. But it's one of those recent
80
ones.
is pretty specialized.
Yeah.
Yeah. Anyway, it's very cool.
Yeah. So you were saying, though, that I should, we were talking a little bit about like auctions and stuff like that as well.
Yep.
Because, and actually, Derek, past guest of the show as well, Derek Kozel had recommended this really good document to me on Twitter about the 8537, I think it is, which is classic. I don't know.
Yeah, it's a HP classic.
Yeah, and there's a bunch of different kits and add-ons that you can get for it. And I started looking at it, and it actually does make sense in a lot of ways. I think it was I think I saw one for $1,500. But a lot of it too. I am not the kind of person that is on the EV blog forum nerding out about this stuff, like all the.
You should be.
I know,
because that's the place to be.
Oh, that's totally the place to be. That's the first place I checked too.
Right. And the buy sell section on there, I regularly post links to auctions. Usually in the US, where they just these whole factories and labs shut down. They shut down the Nokia labs. They shut down some RF they shut down some chip manufacturer, and you just get all these high end VNAs and stuff, and they got dozens of them on there, and that's where you pick up, decent. Be careful though of the the 15% buyer's premium and all that sort of jazz.
What does that
secret mean? Oh, well, these auction houses, you don't just only pay the auction fee, but then there's a buyer's premium on top, which is their fee.
Oh,
basically,
really?
It's actually called a buyer's premium.
Wow. That's
and and it can be 15-20%. Oh yeah, 15-20%. So you think, yay, I nabbed my $10,000 instrument for $1,000, and then you realise that it's a 20%, 30% buyer's premium, and you've got to fork out another. You've got to fork out $1,500 or something.
Yeah.
So just be careful.
Okay.
Yeah, or buyers. Yep.
See, I think the thing for me is that so I'm still new enough in this stuff that I want to buy something I know works at first. I think that certain,
you want
my first scope shouldn't have been a broken scope. It was, but I shouldn't have been a broken scope, right? Because then how do you? I think your first scope should be a working scope, maybe a low end working scope, and then you use that to then you buy your second scope is broken, and then you use that to fix the second scope. You need visibility into that thing and some kind of reference point.
lies the problem in that if you buy something on eBay, right, you're either buying it as is or you're buying it from one of the refurbished test equipment sellers, and they will test it. You can be pretty confident, right, if they sell it, but you're going to pay a premium, like a double what you'd pay for just some individual person selling their instrument as is, right? It's like, oh, it powers on, you know, and they show a few waveforms or whatever, and it passes some self-tests, and you go, okay, you know, you've got to at least have like it's passing its self-tests. The good thing about these instruments is that they do have comprehensive self-tests built in. So if it boots up and passes the self-test, then, you know, you can be reasonably 80-90% confident it's going to be at least usable. Or, as I said, you go to these auction houses, and when these labs shut down, right, they literally have dozens of these high-end instruments in test racks on
with cow stickers
on the production floor with cow stickers and everything, right? And so you can buy one of those pretty confidently, unless it looks like it's beat up or something like that, you know. Then you can pretty confidently. They're just as is pulled from working environment. You know,
got it.
Don't trust an individual seller on eBay when they say pulled from working environment, because but these test equipment auction houses, when an entire factory shuts down, then you're almost like 99% confident that sucker's going to work.
Got it. Okay. Yeah.
Yeah.
And then
especially
if it doesn't
they've
work,
got 10 identical ones and they all came from these test racks. Yeah, guaranteed.
Got it. And then if it doesn't work, you stick it on eBay and you say, pull from
work,
working
pull from working environment, that's it, and you resell it,
that's the thing. I mean, I think like I've never really dove into that world. Like, like I was very lucky to have access to stuff. But now I don't.
Now that you're on your own.
Yep. That's the thing. Yep. It's
and your wanky hacker space that you're living in now, whatever it's. Sorry, what is it?
The workspace. The workspace. The shared workspace
thing.
They don't have one.
Don't have VNAs.
I'm trying to convince them to, and that's
right. Convince them that nobody else would ever need a VNA, but you need one. So.
No. I'm trying to convince them everyone needs one. Don't kid yourself.
Oh, everyone needs a VNA. Everyone needs a 3 gig VNA. Of course they do.
Of course.
To develop their new Internet of Things light bulb.
Well, I think that actually is a decent. That's a decent thing there to say, like, oh well, people, there's RF all around us, dude.
All these startup, that's right. Yeah, you've got to. Even though we just talked about everyone just buys a module and plugs it in and it works,
Well, yeah. That's true. So there is one. I will say there's one that kind of kept coming up. The mini VNA Tiny. It's like $350, depending where you get it. It's from China. It's so that's the one that kind of kept coming up. I had actually wondered about this other one out of Germany. That's called the Pocket VNA. I'll link to both of them. I'd love to know if there's people that are actually using these things. I'd love to know, just because $300 to $400. It's not a ton of money, but it's also like I'd love.
Yeah, but I don't know. You could have a go, I guess, at that sort of price. You could.
Yeah. It's definitely much more doable. So.
Right.
And like it's just for like doing matching, transmission line stuff and antenna stuff and things like that. So
right, yeah. So it's not for full characterization and all that sort of jazz, right? It's just for right.
And so like the things that people kept asking me too are like, what are the frequency you need to do, and then what is like the dynamic range you need, and so like the Pocket VNA does 40 dB up to gigahertz, it said, and then the other one I think is the same range. I think that's the thing. Like if you're getting like an old HP one, you'll get like maybe like 80 to 100 dB of dynamic range, whereas like in these little handheld things, I don't think you're gonna get it. So
70 dB at 500 megahertz for the mini VNA Tiny.
Right. So
they don't give you the spec at 3 gig. they only give you the spec at 500 meg. They say it goes.
Manual.
It goes up to 3 gig. Do they even have performance plots for that?
Right.
Like, do they even? Probably not. Right. And it's like
right.
Yeah, it'll go up to 3 gig, but you've got to practically shout into the thing to, to make it work, right?
Yeah. So if there's other suggestions too, I'd love to hear too. I mean,
all right.
I think this is one of those things like where it is quite specialized equipment, and not everyone's doing it, and that's fine. But I'm trying to.
Yeah, they're very obscure bits of kit. VNAs, vector network analyzers.
Yeah, I think I've never needed them until RF stuff. So something new. So we'll see.
Cool. Excellent.
What else is on our list? Anything else? Yeah, a couple other things here. Oh, there's a talk, actually, another teardown talk. There was a really good talk by Kate Temkin about a new tool set that she's working on for there's a new set of tools. So we had Travis Goodspeed on the show a couple shows ago, and so he was talking about the Good FET, which is now the Great FET, made by Great Scott Gadgets. And Kate works for Great Scott Gadgets doing the software for this thing. Basically, it's a debugging thing. So this is something that you and David might want to look at, Dave. Mm-hmm. I've never looked at USB packets personally. I don't know how they work. I don't know what. I just kind of plug it in and I just cross my fingers. But this is actually a new set of tools that, without having to buy a
USB analyzer, commercial.
Yeah, exactly. Yeah. So those are it's not terrible. It's like $1,200. It's a lot, but it's not. It's like if your entire team was doing it, you need to buy 10 of them. That would be pretty tough. But this is now some of the tools are out there, and Kate gave a really great talk. So
that's something the market is missing is decent low cost USB debugging tools, because if you have to debug it, you have to debug it.
Exactly.
Right? It's what do you
look at it on a scope and you're like, oh look, there's a bunch of squiggles.
There's no point. There's no point.
Yeah.
No, you've got to depacketize that. You've got to decode the whole thing, every single element of the USB protocol. You have to have hardware software solution that decodes all that, often in real time. Right. So
and if you're just looking at the what is your OS doing, and is it enumerating, is it figuring out what device it is? This is a problem I had one of the dev boards that I had. It's you could look in the OS and it's it says, oh, there was an error, it can't enumerate, but past that it's just oh, I guess I just swap it out and try again. You don't actually know is it giving all the things it should be? Is it actually announcing itself, its device ID and all that stuff? So digging in is a lot tougher.
And the problem is that they keep bloody upgrading USB. So it's okay, 15 years, 20 years ago or whatever, a USB 1 protocol analyzer was whoa, that was a real expensive high-end bit of performance kit, right? And then USB 2 came out and go, oh, well, I might as well toss my USB 1 thing in the bin, right? It's useless now. Yeah. So and then USB 2 was what's the speed of USB 2? 400 megabits per second or something, right?
Yeah.
And that actually requires a lot of hardware to decode that in real time, and
Oh, you said
so. That's difficult.
Yeah, the high speed. There's full speed and high speed
stuff.
I think high speed.
Yeah, the full speed and high speed for a couple hundred megs, right?
Yep, I think so.
And so I've got a USB 2 protocol analyzer.
Oh, you do?
Right?
Okay.
And it's totally useless. We're using USB 3 now for the micro supply, and David was complaining the other day that he didn't have a USB 3 protocol analyzer. Oh,
you guys are using the full data rate and everything too?
No, we're not, but you've got to decode the protocol. So, so if you buy a protocol analyzer, it's going to support the full speed, whether you like it or not. Right? That's that's
God,
just the way it is.
I'm so out of my element. I don't even know what these things are. So
So I don't know the intricacies of the USB 3 thing, but anyway, you've got to toss your USB 2 development tool out, and you've got to get a new USB 3, and that's some real expensive high-end hardware. So I'm not sure what this video covers. Is it what these tools cover? Is it USB?
Yeah, it's how the actual software tool chain is working, and then a new interface for looking at it. So it's super cool. Highly recommend it. It was a very good talk, very engaging.
Yep.
So
great.
Yeah.
If you need that stuff, you need it.
Yeah, you really do.
Yeah. But once you're down that rabbit hole, good luck. You're you're in a world of hurt, right? If you have to break out your USB protocol analyzer, you're in a world of hurt.
Yep.
Murphy's gonna beat the crap out of you. So,
yep.
Yep.
How about this last one? We do the open source multimeter. You took some interest in this at the beginning.
There's an multi-source. Once again, the question is why.
Sure.
Sure. And they
because it's there,
cover
Dave.
that.
Because it's there.
Because it's there. And once again, the first thing that they cover on this. Who's done it? So we can credit them. Martin.
Yeah.
Martin. I don't know her last name. It's just Martin has done it on the Embed blog. Anyway, post a link to it. STM32 open source multimeter. And one of the things the first question he answers is why.
Yeah.
And it's like, oh, well, because I wanted to.
Yep.
And, and he's talking about, it can measure power, so voltage and current at the same time, and, stuff like that. And he's got like a 3D printed case, and it's got a little dot matrix screen on. It kind of looks like a multimeter without a range switch, kind of.
Yeah.
Sort of, And it's one of these things. And I've been... discussing open source multimeters for people for probably 20 years back on the Oz Electronics and Sci Electronics Design Usenet groups, right? It dates right back to then. Everyone has the dream of, designing their own open source multimeter back before open source was a thing. You wouldn't use the word open source. I want to design my own multimeter, and it's open by default, kind of thing. And and it's one of those, they always, it's such a complex thing that, you have to ask why. And it's like, just because you want to is the only answer.
I think so. I mean, I think the hope is that the longer term it'll build on itself and that kind of thing. But
but then nobody wants, and then everyone has a different. The problem is, even if you have, like on the EV blog forum, world's biggest test equipment nerd forum, right, with so many people. What?
Sunday. Join the EV blog forum. Go on.
Join today, don't delay,
That's
as
right.
Lewis Rossman would say. Join today, don't delay. Okay. And, anyway, right, there's so many people have gotten on there. I want to design my own open source multimeter. Everyone goes, great, let's design it. Let's design it together. And then all hell breaks loose. It's like, it's fun to watch. You just grab your popcorn and just watch them tear each other apart because everyone wants something different. Yeah. It never works.
Yeah.
It just
I think there's the collaborative hardware thing is tough too, but yeah.
Yes, it is. As I always say, one person has to drive projects like this. It has to be ruled via a dictator. One person, does it.
Yeah, I think that's the 80% rule at least. Yeah.
These open source hardware things never. Yeah. Open source collaborative projects, everyone just wants something different.
Yep.
So there's just no point. Even if you agreed with all the specs up front, and like you can't even do that.
Yep.
Right? It just doesn't work because you go, we can't do that because, that spec, if we lower that spec by, or if we increase that spec or whatever, widen it by 0.1%, we can save an extra $10 in parts, right? And you always have to be willing to be flexible.
Yeah, if it makes people feel better, having worked at a test equipment company, it's exactly the same there. It's just there's more on the line because people's jobs are actually dependent on it too. It's as much of a shit show, so if not more.
Right. But somehow you get it done because it's your professional job,
Sure, yeah.
Yeah, right. Yes,
eventually.
as you said, your livelihood depends on it, right? Yeah.
Yeah, so this is a great little project, though. I like it.
Anyway. Yep.
Yeah.
So, sorry, it just, I just chuckle inside every time I see open source multimeter because I've been dealing with it for 20 years.
Yeah. I mean, I think at the end of the day,
it's hilarious every time.
I think, the things that I think about with multimeters, too, is, you need good non-drifting components is very important. That makes it expensive. Even if it is open source, that's what ultimately makes it expensive. Any test equipment has, purple screws like that. And then good protection, no matter what.
That's the first thing I think about when I think about multi. Two things I think about: safety, reliability.
Yeah.
Right.
Yep.
Confidence.
Yep.
Right. Measurement, confidence.
Yeah, exactly,
right?
exactly. You don't want the second thing next to it saying, that's wrong.
Yep. Yeah, it's safety and measurement confidence. And it's a proper multimeter is all, certify. You can plug it into mains and it's not going to explode, right? Or if it explodes, it's contained inside and it's not going to blow your hand off when you're holding it.
Yeah, yeah.
Kind of thing, It's one of those, yeah. Anyway, yep.
I forget who I was talking to the other day. It was a couple days ago, weeks ago. Time is a circle, Dave. I don't remember when I was talking to this person, but they were talking about the cost. Was it on the amp hour? Good Lord. But they were talking about the cost of standalone ADCs. Was that on the show?
Yeah.
And like how there's a bunch of micros now where the cost is, the ADCs are good enough that there's a micro in there and they're using it as, using it for the micro internally, like versus for the ADC internally.
For the ADC, so they were using it as they were using a micro just as an ADC.
Yeah. Who was that?
Right, like via the SPI interface or something.
Yeah,
like
exactly. I mean, I think it's just
why? Because it's cheaper.
It was cheaper.
The ADCs in micros are usually a bit.
Yeah, I agree. But this particular one.
Okay. Yeah. Right. No, you're always going to meet there's always going to be some sweet spot where, yes, it's going to be cheaper and better.
Yeah.
Just to do that. That doesn't surprise me.
Yeah. I just think about
really.
like when I start thinking about going down the line of things that start to trip people up in test equipment too. It eventually gets to the ADC. That's why I was thinking about that as well.
Yeah.
So.
But it's always specific. You can't just go, micros with ADCs are going to be cheaper than an ADC.
Yeah, of course.
That's just rubbish,
Right.
Yeah.
No, yeah. Right, then the really crazy people are like, I'll just build my own ADC. What could possibly go wrong?
Yeah, right, yeah.
You guys saw the current source is doing that right now, the YouTube channel. Yeah.
Oh, is he?
Yeah.
Okay. Right, yeah. Great. Love it. We didn't talk about Maker Faire laying off all this staff, did we?
Yeah, we did last time. Yeah, we did that 2 weeks ago.
Okay, yeah, done. Okay,
yeah,
all right.
Yeah.
All right.
They're still laid off, if that's the thing.
Yeah, they're still laid off. Right, yeah.
Sorry.
Have you heard what's happened to the IP?
No.
No? Okay.
Oh, I thought you knew. Oh, you're just asking.
No.
Got it.
No, sorry.
Yeah.
Simone Gertz made the Tesla the truckler.
Oh,
that was
man.
cool.
That was.
We won't go into details, but that's
if
awesome.
people haven't seen that, it's fantastic.
When I first heard about that, I thought, she's just going to hack this thing. It's like, no, she got a proper team together. They hired a warehouse and they shot this professional commercial for it. And it's like, holy crap. I actually ribbed her when she said on Twitter that she bought a Tesla.
Oh, yeah.
And, and I didn't know, apparently nobody knew she was buying it for this specific purpose to chop it up.
I remember her tweeting about that.
That's why she bought it, yeah. That's why she bought it. Anyway, that was very cool.
What did you say? You said don't turn it on, take it apart, that kind of thing, or what?
No, I said because she's the queen of shitty robots, right? She builds shitty robots. That's what she does. And my tweet was tongue in cheek. I couldn't help myself. I thought it was so hilarious, saying, I thought you built shitty robots, not bought them.
Oh.
And it was like,
I think the Model 3 is nice.
So it's very nice.
You're just jealous.
Car,
You're just jealous. You can't get one.
I'm just having a poke at all the Tesla fanboys, and it got a great reaction. It got I was trolling,
of course,
and I thought it was brilliant. Everyone, that most people got my troll. Everyone went, thumbs up for the troll, Dave.
Yes, right.
And most people got it. So.
Classic Dave. Yes.
Anyway, I thought it was funny. It was a joke.
Of course.
Yeah.
Yeah. No,
anyway,
that build was really good.
Yeah, she was buying it for that specific purpose. So it's very cool.
Yeah.
Yep, that's great. I hope she got her money back. I hope the advertising revenue for the millions of hits she got paid for the car. Maybe if it gets 5-10 million hits, it'll probably give her 30 grand in ad revenue. So it could pay for it. Maybe.
Yeah, hopefully.
Yeah, maybe. I haven't checked the numbers on the on the video, but yeah, definitely. Oh yeah, she's got 7.5 million views just on the build video.
Yeah.
Just on the build video. So that's impressive. So if I search for, hang on, I've got to do hang on. 1 minute her video 5. Oh, she's got more. That's interesting. Wow, I didn't expect that. She's got more views, 7.5 million, compared to 5.3 million that she got for that real polished 1.5 minute commercial that she put together. I thought that commercial would have gone gangbusters, right? Would have been shared to the hilt, whereas more people watched the 31-minute build video.
Yeah, right.
Wow. Okay.
Good job. Good job, public.
Yeah. Yeah, good job, public, for watching the whole, for wanting to watch the 31-minute and sharing the 31-minute build video.
Yeah.
Oh, no, I know why. Of course. Duh. Full-time YouTuber Dave, of course I know this, is because YouTube do not value a 1 minute 46-second video anymore. The watch time isn't there. So it doesn't have a chance. Yeah, even if everyone watches the full 1 minute and 46 and it gets millions of views in the first day, the algorithm isn't going to pick it up and snowball that one. It's just going to devalue that video because it's not getting the watch time. And that's what the evil algorithm wants these days. Whereas the 31-minute video, okay, it might get the same number of people initially in the first day starting out watching it, but they're going to watch an average of 7 minutes, 10 minutes.
Right.
Yep. And so therefore, boom, it starts accelerating in the YouTube algorithm, and that's what snowballs it. So it might have even started off with 1/10 the number of viewers as the commercial, but in the first day, for example, you might have got 1/10 the number of views, but the algorithm accelerated that because it had 10 times the watch time. So yeah, and there you go. Interesting. So hang on, I'm just doing some calculations in the back. 14 times 2. Yeah, she probably would have got. Maybe, if she's lucky, got close to 30 grand for those 2 videos in ad revenue. Yeah, so it's close to paying for it. So cool.
That's great.
Cool.
That's great.
I don't want to be out of pocket, but she has a truckler now.
Yeah.
So
it's its own reward, really.
Yeah. It's its own reward driving that baby around. Yeah. That's great. Anyway, we're way over time.
We are.
That's it.
All right.
Call it quits.
See you in a couple weeks.
Catch you next time.